So in this example, what we are going to do is that we will understand how to manage our data analysis process in Stata using secondary data and data cleaning process and data analysis process. This is one example file. I will start with, first of all, make sure that my data has short names because Stata requires coding. If your names are longer, you have to write longer codes. So what I will do, because this is a panel data, I will add first of all a new row so that I can write short names for the variables that I'm going to use. First of all, I need to use country because it's a panel data. So I will write country here and here. These two variables are very important if your data is panel data. If it is time series, then the year variable is important. If it is cross sectional, then country variable is important. Otherwise, Stata will not recognize it as a cross sectional or time series or panel data. It will consider it as a set of data sets, set of numbers. It will not give any specific value. For example, you want to do time series analysis and there is no time variable. Stata will not be able to do any time series process because it does not know how data is changing in time. Similarly, if it is a panel data and if you don't have cross country or year variable, Stata will not know how the data is changing. It will not be able to do any panel data analysis. Now I will take one variable that is GDP per capita. For that I will write a short name GDP, and then there is one variable GCI. This is competitiveness. This is one of my independent variables. I will write two or three more, and I will also take like for example I will take I've taken GDP. I will go forward and I will take a variable that is labor force participation LF and gross fixed capital formation, which is called capital. So K. Okay, I will try to make sure 3 or 4 letters maximum, and then I will say use fossil energy demand. So FOSS. So these are 5 variables that I take. What I will do next is I can directly import it, but best way is to either hide the variables that you don't need, hide the cells, so that you only have, or cut the column and move it forward. I will not cut because if I have added any formula, it will be disturbed. So I will hide these cells with up, hide, and then hide these two. So I don't have to hide the next one because I'm not using them. So control shift right and down. It has highlighted all the data. I will press copy and I will go to Stata. Now I will go through the checklist. So first of all, I will import the data using pressing this button, do data file editor. In that I will control V, press paste. It will ask if your first row is a data or a variable name. My data said it was variable name. So when I press it, it will import the data. First thing you need to check when you import the data is that other than country name, none of the data should be red. Red means that data is string, alphabetical data. Our data is numeric. So none of the variable should be red other than the country name or any other variable which is you know that it is alphabetical, like continent name or district name or any other name. But we know that GCI, GDP, FOSS, labor, LF and LK are numerical data. It should be red, black. If they are red, there are two meanings. First, either you included the variable names as a data. When I was pasting, if I said the first row is data, it would have considered the variable names as a data and all the variable would have been red. I will show you that example again. If you want to remove the data, just write clear, data will be removed. I will go and paste the data again, Control V, and say that first data is data. So now you notice all the variables are red. Why? Because at least one observation in each variable is alphabetical, year, GCI. That's why it is red. Second reason can be that in your data set, one of the observation might be dot dot or NA, that is also alphabetical data. And if that alphabetical data is there, that column will be shown as string variable or in red. Now this was the first checklist that you need to see. So I will clear it again and import the data, control V. It will not paste because I have removed the data from the memory. I will go here, control shift right and down, control C. Okay, so when I come to the data editor, control V, variable names. Now the data is at least one problem is solved, that there are no string variables in the numeric variables. Stata will not use the data as a numeric if there are alphabets in the data. Yani Stata will consider data which has alphabets as a string data, and it will not cannot be used in regression analysis. ठीक है, so this was the first checklist. यहाँ से ये क्लियर हुआ कि डेटा में कोई भी जो न्यूमेरिक डेटा होना चाहिए था वो स्ट्रिंग नहीं है. इसका एक और तरीका भी था कि we can go in Stata and write describe. It will describe the data. So first variable is str31 string. Here is integer. Integer are the variable which are not in decimal places. Yes, our year data cannot go in decimal places. All others are either float or double. Float variables are those variables which can go in decimal places. Double variables are those which can have two decimal places up till 8 decimal points. Okay, so float होता है 4 decimal points तक, after decimal 4 values, and double is 8 values. So for us both are same, both are numeric. Okay, so this way we know that what is the nature of the variables. If your GCI, GDP, FOSS, LK and K are str31, it means there is one problem, and there are only two ways of that problem. I talked about that. दो तरीके थे, discuss हो गए. Next thing you need to see is you need to tell the data Stata that it is a panel data. You need to tell Stata that it is a panel data. So for that you need to tell which variable is a here variable and which variable is a country variable. Since our country variable is alphabetic, we need to convert it into numeric. For that we write a command in code. Commands are written here. In code country generate ID. So it will code the data. First country will be considered 1, second country considered 2, so on. And it will create a variable ID. And when you write this, and if you go press page up and go to the describe command again, 2 times page up, now it will show that the ID is long variable. Long means it is a data with some codes. It has 2 layers, alphabets and their codings. So if I open up the data file, from here you can see ID is in blue. Blue means it is encoded data. Even though it looks alphabetical, but for Stata it is numeric. Numeric is तरह, first country is 1, second country is 2, and so on. So backend में numbers है. Stata considers this data as a number, but it shows us as alphabets, because alphabets is the meaning, numbers is just a reference value. Okay, so यहाँ से we converted the string variable of country into year. Now we'll tell the Stata that it is a panel data. For the command is xtset. xt means for Stata, xt means panel data, cross section time, and set means setting. Xt setting, and we'll write id here. So this command, when you run it, it will tell Stata that your first id variable is the cross section variable, because x is first, then t, and our here variable is time. So it is saying that panel data is based upon id variable, and it has time variable from 1980 to 2003. It has some gaps. Gaps means if for some countries some years are missing. It's not a problem for us. If it was a problem, it would have been written in red. And delta unit 1 means that the number of years are changing by 1 unit. So there is no, sometimes your data is that every observation comes after 5 years. Then the delta unit will be 5. Here the data is annual. Every year has a new value. That's why data unit is 1. So now Stata knows that it is a panel data. Now next step is you need to make sure you need to describe your data and you need to clarify if you have to transform any variable. So the command is sum or summary and variable names GCI, GDP, FOSS, LKK. Okay. So variable names are here. I will try to make sure that I can increase its font size. Font and let's say 16. Is it viewable now? So I now need to make sure that variable names are same as what are shown here. And you need to make sure they are small enough, otherwise you have to type again and again. Time बचाना है, variable names छोटे रखने हैं, you can remember it yourself. Or if you want to make sure that you need to remember it properly, before running this command, you can go in the data file and you can click one variable at a time and click the variables option and properties and click the variable and write its label. It's a country name. Add a label. So this is this variable is GCI. It is competitiveness. Now next variable is let me make it permanent here. This is GDP per capita. Advantage of adding label is when you make a graph, it will not show the small name, it will show the label. So for that, it will be easier for you. Fossil, energy, demand. Okay, then labor, force, participation. Okay, and then physical capital. Okay, all the labels are here. So I will close. You will see the codes how to add label manually. If you want to add label, variable name, and then what you want to add as a label. Okay, so for example, one of the variable I have not added a label. So label, a variable year and time periods. Okay, it's not worked. Time periods now. It has added a label for that. Now, whenever you do any analysis, it will show you the full names in the graph. Now we'll do the summary. sum, and you can the order of the variable does not matter here. GCI, GDP, FOSS, LF, LK, K. LK is not there. So it has shown as observations, mean value, standard deviation, minimum, maximum. If you are presenting it somewhere, you can increase the font size by going in font and making it bigger. So these are numbers here. Some people who are using Stata sometimes confuse how to read this number. So this number is 5.39 into 10 raised to power 11. It means 5.39 multiplied by 1.000000 and it has 11 zeros. Okay, so this is the such big number. Okay, similarly standard deviation 4.17 into 10 raised to power 12. Minimum is 2.16 into 10 raised to power 7. Maximum is 9.00 into 10 raised to power 13. Now, what is the first purpose of descriptive stat is, this is descriptive statistics, mean median model. Descriptive statistics. So it means in your results, first heading will be descriptive statistics. You run this command. Okay? This command does not will help you to get you mean, standard deviation, minimum, maximum. You can get more things, but for that the command is a little bit different. I will write it here. That is tab statistics table, variable names GCI, GDP, FOSS, LK, LF, K, stats, and mean, median, you want SD, you want variance, you want IQR, you want minimum, you want maximum, you want the percentile 25 value, percentile 75 value, you want skewness, you want kurtosis. When you press enter, it will give you all the things. So this is more detailed descriptive stat. You can use this. But usually you only want to show those numbers, those that you know how to explain. सर वही दिखाने चाहिए जो इंटरप्रिटेशन में लिखने आने आते हो या वो कहीं यूज होते हो यूज समवेयर लेटर ऑन or you know how to interpret them. Otherwise, don't use too many things. Second, you might also know what is P50. This is median. SD is standard deviation. Variance IQR is interquartile range. This is P75 minus P25. Okay, and I didn't ask for range. It would have also given me range. Range is maximum minus minimum. And then we have maximum, minimum, 25 percentile value, 75 percentile value, skewness value, kurtosis value. Okay, so I use this descriptive stat for two purposes. First purpose is to decide for which variable I should take log. Okay, so for that I look at the mean values. The mean, I will take a log of a variable which has most different mean value. For GDP, it is biggest. Others are less than 100, and the GDP is beyond 10 raised to power 11. So it means if I need to do analysis, my result will be better if I take log of GDP, because it should be. So it means I will create a new variable, generate gen LGDP, that will equal to ln GDP. If I write this command and press enter, a new variable will be created, which is ln GDP. I will press page up 2 times, and I will also add LGDP here, and also add the range. So now have a look. The log of GDP is 23, mean value 23, and others are also near. GCI is 4, GDP is 23, FOS is 65, LF is 61, K is 22. There are, other than GCI, all others are near. So there is no need to take log unless your GCI is dependent variable. Okay, if GCI is dependent variable, I might also take log to FOSS because it is now biggest, and also LF. But if your GCI is not dependent variable, it doesn't matter. For my example, GDP is dependent. Okay, this was the first step. It tells us which variable should be converted into log, data transformation. It is clear now? Okay, so the best criteria is to check the mean values. There is another method I will show you when I will do the regression. But this is faster, you don't have to do many steps. Now, second step is you need to interpret this table. When you have this table, first thing that you can describe is that if the data is normally distributed or not. Normally distributed or not. For that, the criteria is the skewness should be 0 and kurtosis must be 3. And in these variables, other than the LF, where the skewness is minus 0.06, it is near to 0, and kurtosis 3.1, it is near to 3. It looks like it is normal, while others are not normal. Clear? So data to be normal, skewness must be near to 0, kurtosis must be near to 3. It is near to 3, but its skewness is not near to 0. And for others there is no. And you also know why I took a log, because this skewness and kurtosis were too big. When I took a log, they are very near. As compared to 241, 3 is near to 3.0, is near to 3. So it means when you take a log of a variable, it goes near to normal distributed variable. That's why this is the second reason why we take a log. First reason was to reduce the size. Second, to make it look like normal distributed. So this table tells us which variable is normal or not. Other things it can tell us, there are other ways to check if the data is normal. That is, if the mean and median are equal. If the mean and median are equal, the data is normal. So and none of the variable has mean and median equal. Closest is this one, 6.019, 6.09. It is closest. That's why it was also saying it is normal. Okay, this is the second way to check if the data is normal or not. Third thing that I usually do is I compare mean with the variance. Mean with the variance. If the data has mean value higher than the variance, it is called that variable is under dispersed. Under dispersed, kam bikhra hua. Under dispersed. If the mean is bigger than its variance value. And if the mean is smaller, over dispersed, zyada bikhra hua. What is the meaning of this word? Under dispersed means, I will give you some background. This is a panel data. There are many countries and many time periods. If the data is under dispersed, it means the variable has a similar properties across all countries. वो सारे मुल्कों में एक जैसा बिहेव कर रहा है. That's why it has a mean value bigger than the variance. It means that variable has some significant patterns in it. That's why its patterns are adding up and its variance is smaller than the mean value. If the mean value is smaller than the variance, it means that variable is different in countries. There is no commonality. Country wise वो data फर्क है, हर मुल्क का अपना style है उस variable में, and that's why it is very scattered. So it means there are no patterns in it. Clear? So for example, GCI mean value is bigger. There are some patterns. GDP mean value is bigger. Fossil energy mean value is smaller. Labor force mean value is smaller. Capital mean value is smaller. Okay, so it means we have two variables which are under dispersed, three variables which are over dispersed. So if your data has some variable under dispersed, some over dispersed, it means if you do any analysis, the country differences matter. Country differences matter because there are few variables which are homogeneous across countries. यानी हर country change होता है लेकिन data में pattern कम बदलता है. And some variables which are heterogeneous across countries, कि वो country में सब में फर्क तरीके हैं, कहीं में बहुत बड़ा है कहीं में बहुत छोटा है. So it means if you are doing an analysis which is a panel data and you have under dispersed and over dispersed variables, you need to use appropriate panel data model, not simple regression. It will give wrong results. Simple regression will ignore that all variables are homogeneous across countries. अगर हम simple regression रन करते हैं तो वो कहेगा भी सारे मुल्क एक जैसे हैं. यहां तो पता चला एक जैसे नहीं है, तीन वेरिएबल ऐसे हैं जो कंट्री वाइज बहुत बदलते हैं. उसको एक और तरीके से भी चेक किया जा सकता है. आई विल शो यू दैट थिंग कि हाउ दे आर डिफरेंट अक्रॉस कंट्रीज. यहां पे क्लियर हुआ? एनीवन हु हैव अ क्वेश्चन हियर? सो दिस इज the thing. Now it is giving us a signal that you need to use appropriate panel data model, not simple regression. So once we have discussed this table, next thing is we need to confirm if the variables are normal or not. For that the command is skewness kurtosis test, SK test, GCI, GDP, or we don't need GDP now, LGDP, FOSS, LFK. This is skewness and kurtosis test for normality. If you look at the last column, all of them are less than 0.05. Last one which is not available is also less than 0.05. It is saying there is no need to calculate because it is so small. Dot means less than 0.05. So all of them are significant. It means they are not normally distributed. Not normally distributed. Okay, so we have confirmed if they are normally distributed or not. Next stage is to describe their association. So now we are going to do association. For that, the command is correlation, GCI or LGDP. I will move the dependent variable first. GCI, FOSS, LFK. This is a correlation matrix. It is telling me that there are 781 common observations in my data. Common observation means there are 781 rows in which all 5 variables have the data. There after removing the missing values. Okay, and now first column is the correlation of the independent variable with the dependent variable. First value is 0.63. It is telling me GCI is correlated with GDP by 63 units, or the correlation is 63.63. So it is also called strong positive association. Second variable is 0.32, weak positive association because it is less than 0.5. 0.04, weak positive association. 0.02, weak positive association. So it is telling me all of my independent variables are positively related with dependent variable. Correlation has positive value, so they are positively related. Correlation is telling me that the correlation is positive and there is some number, so positive correlation only. All other columns are correlation of independent with independent. Correlation of independent with independent. Theoretically, the regression says that your independent variable should have very small correlation with each other. And high correlation with dependent. It means ideally we would like that first column has big values and other columns have small values. Okay, why we need small? Because the regression says that independent variables should be not correlated with the independent variables. Otherwise, what will happen? It will lead to a problem which is called multicollinearity. You already know this name. According to econometrics, if these correlations are less than 0.9, means 90%, it means there is less chances that there is multicollinearity. So in my case, none of them is above 0.9. First one is 0.25, 0.14, 0.05, minus 0.28, minus 0.08, minus 0.06. None of the independent variable pair has a correlation higher than 0.9. So there is less chances that the model has a problem of multicollinearity. Usually panel data method helps us to reduce it, so that's why it is smaller. Take again. So this is the second descriptive stat correlation analysis. यहाँ से clear हुआ? Next step is you need to create graphs of your dependent variable with independent variable. So I will show you few examples here. First is you have to write two-way. I will tell you what is the meaning of two-way. First of all, we will add scatter of LGDP with GCI scatter plot. And then I will say comma, I write title. Title of the graph should be GDP and competitiveness. So you need a title after comma. When I press enter, it will make me a graph. It will take some time. You can see graph. Since I have not added a label for GDP, LGDP, that's why the full name is not here. But for GDP, the label is here. So what I can do next time, I will add a label. So the command was label variable LGDP log of GDP per capita. Okay, now if I make the graph again, the label is there. So it will save your time. If you don't add labels, you have to manually write the labels. How to manually write? What I will write it is at, for example, in this graph I will write X title, gross GCI, competitiveness index. So it has changed. So if the labels are not there, you can add the names. Now this is the first level. Second, if you want to add some other things, like you need to change the font size or bold or change the color, you can just make it size bigger. Go here, edit graph, and then double click the title. You can go there and change the size, change the color. I want to change it to, let's say, red. Okay, apply red. Okay, similarly, if you want to change the color of the y-axis title, double click it. You want to change the size, color, margin, or any other thing that you want to change. Okay, so this way you can have, if you want to add a subtitle, this is the option shown there. Double click it and write scatter plot. You have a subtitle. You want to add a caption. Some people write a caption. You write source World Bank. So caption is it. So many things are shown here. You want to change the type of dots. I will click it here. Double click. These are circles. I want them to be triangles. Apply. It will become triangles. I want them to have different color. So triangle medium color navy. I can change it to red. Apply. Become red. You want to add some other properties. You can use it here. Okay. So this way you can update your graph and then press copy and paste it in your Word file. Clear? So this way you can make your graph. So try to make one graph for each independent variable. So this one was for first dependent and first independent. So I will do page up and then change GCI it with FOSS and then change the title to fossil energy and then remove the subtitle. Yeah. Now you want to beautify it. I showed you how to do it. इस तरह आपने सारे ग्राफ बना लेने हैं. आपके 5 वेरिएबल होंगे, 5 ग्राफ बन जाएंगे. ठीक है. Now there is another advantage of using graphs. You can also have a look what kind of transformation you need to use as a variable. For example, I will go in the competitiveness, remove this subtitle. I will also add one more command, that is qfit, quadratic fit. LGDP GCI. It will add a line which is going from the middle of the graph. ये line if the line is straight, it means you have a linear association. If the line is bending, it means there is a non-linear association. If it was bending, I will find some more example. Now I will make an example for fossil energy and I will add the qfit here. qfit LGDP. Line is little bit bending. It is not straight. It means there is a quadratic association. It means when I will do the regression, I should add square of this variable. Square of this variable. This independent variable. So how to generate a square variable? So gen FOSS2 is FO multiplied by FOSS. A new variable is made. So we have already done descriptive stat, correlations. We decided which one variable we need as a log. We decided if we need to take a square or not. Now we come towards simple panel data. So simple panel data command. First of all, yes, simple panel. So xtreg panel data regression. Dependent variable LGDP, GCI, FOSS, FOSS2, LFK. These are my variables. If I press enter, it will give me panel data results. So before going interpretation, you need to first of all look at one important thing. So first of all, look at sample size. It should be big enough. At least 150. It is 781. ठीक है, panel data में कम से कम 150 होना चाहिए. It is bigger than that. Second, how many countries are there? 113. It is too many. You should know how many countries you have selected and how many are there. For example, you have selected data of 30 countries and it is showing 32. It's a problem. क्या प्रॉब्लम होगी? आपने किसी एक कंट्री में स्पेलिंग चेंज किया, उसने उसको 2 गिन दिया. ठीक है? So you need to make sure you know how many countries you have. This number should not be bigger than that. Otherwise, it means there is a typo error in the country names, and the data is considering them 2 countries. For example, in the World Bank, the Korea is 2 types: South Korea and North Korea. Okay, and South Korea is written as 2 ways: South Korea or Republic of Korea. And you mix that, you add both of them. Yes. So first thing you need to check country groups. Usually when you will be doing your project, your country will be not many. You will be doing on South Asia 8 countries. You will be doing on Asia 40 countries. You will be doing on Gulf countries 10 countries. So you will be able to count how many are they, and this number should not be bigger than that. Second thing that you need to check is average number of observation per group. It is number of years per country. Average years per country, it is 6.9. If this number is less than 19, you can use static panel data models. If it is more than 19, you have to use dynamic panel data models. There are 2 major types: static panel data, dynamic panel data. So it is less than 19. So in this example, I will talk about static panel data models. Okay, this thing you need to just. Second, you need to have a look that majority of your variables should be significant. How you check for significance? Their p-value should be less than 0.05. My variables are 1, 2, 3, 4, 5. All of them are significant. At least 3 should be significant majority. Okay. Once this is done, it means you do not have to do dynamic panel data. It means you can continue. If it is dynamic, then you have to do specific corrections in the data. Okay. So for example, I will give you some hints here. If it is dynamic panel data, you have to do panel unit 2 test, panel co-integration test. That is compulsory. If it is static, you don't have to do these. Okay. Clear? Now the next command is you have to check for if there is cross-sectional dependence. Okay. So we have confirmed that there is a square variable that we know how to find using scatter plot. We have confirmed which variable requires our taking of log. Here in this table, still there is a hint that you can take log of LF and K because their coefficients are very small. So when you do regression, we have taken log of GDP using descriptive stat. But how to find if any other variable requires log? You can look at the coefficients. Other than the square of FOSS, which is a part of FOSS variable, we don't have to take a log of that because it's an extension of FOS. If you take a log of FOS, you have to take a log of FOS square. But since there is no need to take a log of FOS, there is no need to take a log of FOS square. But comparing with GCI, LF and LK are very small. When the coefficients are very small, it means that the independent variable is changing faster than the dependent variable. When the coefficients are small, it means independent variables are changing faster than dependent variable. It means you need to take a log of independent variables. Here it is not compulsory because they are already significant. But taking log has some advantages that I may tell you later on. First of all, let's take a log here. So I will take gen LLF is equal to ln LF. I've just added one L extra meaning of log, and gen LK is equal to ln. ln is natural log, not log base power 10. So I have taken a log. I will do page up, page up, page up, and I will change it to LLF and LK. Page up means previous command. So I will have to go 3 step up. So 3 times page up. So now the coefficients are stable, but the problem is the first coefficient is very small now. Okay. Now you have to take a log of that variable. So Jn L FOS is equal to Ln FOSS. Jn L FOS 2 is equal to L FOS into L FOS. Usually people, what they do a mistake, that they take a log of F4SS2. You cannot take a log of a square variable because it will become 2. You know the rule. If you take a square log of a square, it becomes 2 of that square. So it will not remain a square variable. So you have to create a square variable again. That is L FOS multiplied by L FOS. हम स्क्वायर के बाद लॉग नहीं लेंगे, लॉग पहले लेंगे, स्क्वायर बाद में करेंगे। ये लॉगरिथम का रूल है कि जब स्क्वायर वेरिएबल का लॉग लेते हैं तो 2x बन जाता है। x स्क्वायर का लॉग लो तो 2x हो जाता है। हमें तो x स्क्वायर चाहिए, तो गलत हो जाएगा। तो हम क्या करेंगे, l log of x मल्टीप्लाई बाय log of x करके log of x स्क्वायर बना लेंगे। तो ये बन गया पेज अप पेज अप पेज अप एंड now you see the coefficients are very stable. All are between 0 and 1 or 0 and 0.5. Very near. 0.3, 0.5. This is part of that. Ignore it. 0.3, 0.1. They are very near. It means this equation has stabilized. So that's why we take a log. The advantage of stabilization is it will reduce the chances of heteroscedasticity later on. And we will check that later on. Secondly, in most cases, it makes sure that variable coefficients are significant. It was significant anyways, but if they were insignificant, it will try to make it significant. Okay? यहाँ तक clear हो गया? Now we decide which model we need to run. For that, first of all, we need to calculate the cross-sectional dependence. For that, we command is xtcd and variable names lgdp, gci, lfos, LLF, LK. We don't need to use LFOS square because it is a part of LFOS. If LFOS has a problem, LFOS square has a problem. We don't need to check it separately. When we run this, it will not run because it is saying that the sample is not balanced. For that, there is another command xtcd2. You might have to install it. I will tell you how to install, but it does usually take some time to run. It is adjusting for missing values for all variables one by one. It has given me these results. If you need to install it, the command is ssc install xtcd2. It will install that library into Stata. You only have to install once and then you can use xtcd for any time that you want. Okay? So here h0 is weak dependence and h1 is strong dependence. So in all cases, the probability values shown are less than 0.05. For LGDP, other than 1, all are less than 0.05. For GCI, other than 1, all are less than 0.05. So majorities are less than 0.05. It means there is strong cross-section dependence. It means the data across countries is correlated. Data is correlated across countries. This is called cross-sectional dependence. Autocorrelation is another word, which is data correlated across time, which we already studied, autocorrelation. This is cross-section dependence, which is data correlated across countries. If this is significant, then, so I will give you some background. If there is no cross-section dependence, the model that we use is called first generation panel data models. When I add star, it means it's just a comment. It is used when there is no cross-sectional dependence. First generation model. The examples are fixed effect, random effect, FGLS, etc. These are some common models that are used if there is no cross-sectional dependence. Okay, the model that I showed you above was random effect model. Random effect model. Since there is cross-section dependence, This model is not the final model. Okay. If the data is second generation, panel data models, they are used when there is cross-sectional dependence. Okay. So in this video now we'll go towards second generation model, and I will then later on I will also give you hint for how to use first generation. So we'll start with first generation as an example. So first generation, there are two major models, XT-reg, and I will copy the variable names from here, LGDP, GCI, LFOS, LFOS2, LLF, LK. So first model is called fixed effect with command and comma FE. So this is a fixed effect model, and it is showing all variables are significant. Okay, and all of them are positive except alpha square. I will interpret this alpha and alpha square later on to tell you how to interpret a square variable. But first of all, we have to finalize the model. So when you use first generation model, there are two major types, fixed effect and random effect. You need to decide which one you have to use. For that, we use Hausman test. You might have studied that, Hausman test. So for that, first of all, we'll command estimates store FE to store these results. Now we will run random effect model. For that, we write command and RE. These are random effect model results. Estimates, store, RE. Both results are stored in the memory. How to check? How to test now? Hausman, FE, RE. These are the Hausman test results. Okay, and the coefficient here. So usually there is a p-value shown here, probability value. If the p-value is less than 0.05, it means we will use fixed effect. Okay, so p-value of Hausman test. If it is less than 0.05, then FE. If higher than 0.05, then RE is the appropriate model for interpretation. Okay? So since here the coefficient p-value is not shown, it means it is very small as compared to 0.05. So it means we will use fixed effect model. Okay, so it means the model, this one was random effect, it is shown with command RE. This is fixed effect. Then you will start its interpretation. I will give you one example. First of all, you will start with R square. Overall R square is 0.36. So my independent variables are explaining 36% change in dependent variable. First variable is GCI. If there is 1 unit increase in GCI, GDP growth increase by 0.29. Okay. Then labor force. If there is 1 unit increase in labor force, GDP increases by 0.358 units. And if there is 1 unit increase in physical capital, GDP growth increase by 0.12 units. Now this variable L FOS and L FOS square. So FOS variable is 0.63 and square is minus 0.17. So it is saying that if there is 1 unit increase in fossil energy, there is 60.63 units increase in GDP, but this increasing effect is diminishing by a rate of 0.07. So it is increasing by 0.63, but it is slowing down at a rate of 0.07. It means it will slow down and come down. So it's inverted U-shaped relation. Inverted U-shaped relation. How to draw this? I will create one example. Now you have a variable that is square. For that you need to plot it. For that you need to open a website named Dawson Interaction. it will open a website where there are templates available interpreting interaction effects. So when you open this website, it will show you one Excel file. This. So yeah, I need to go down and I need to plot a quadratic effect. So I will download this file, quadratic regression. So it will show it here. I will download this file and open it up. Okay. And then when it's opened, I will make them enable editing. I will move it to half screen and bring the Stata output in remaining half screen. Now I need to plot this square effect. So my independent variable is alphos. My independent variable coefficient is 0.63222757 and its square variable is minus 0.0740195. Constant is 21.0297 and I need mean value of IV. That's why we did descriptive stats. I will go on the top and I will look at the I will just write sum alphos and I will see its mean value again. Page up, enter. So mean value is 4.04, 462. Standard deviation is 0.7112. When I press it, enter, and I will double click this y-axis, and I will adjust the scales. This is my graph. It is showing the effect of fossil energy on growth. So this is my inverted U-shaped graph. So you can copy that and paste in your Word file. Once you already have a graph, you can make it, you can neat it up by going into format, design. You can add a better layout. I will select this layout. It has a title. You will add title as if you have a square variable. Fossil energy. Now y-axis is our GDP. I will go here and add a label, axis label where it is axis titles. Y-axis I will write it here, log of GDP. You can delete this if you want. This is your graph. So if you have a square variable, you can make graph like this and then explain. So it is showing that initially fossil energy is beneficial, but if you overuse it, it will destroy the environment and it will harmfully affect growth. That we have already studied in our environmental economics class. This is called environmental Kuznets curve. That if you overutilize the natural resources, it will pollute and it will reduce the GDP. Okay. Now in the commands, this was the first generation. Next is second generation. Second generation, for that I need to find this scroll. Need to find the command for the model. XTSCC. So second generation panel data command is XTSCC and the variables LGDP, GCI, alphos square, LK, LLF, and then you are write FE lags 1. Lags not allowed means the spelling is wrong. It is lag 1. This is the model of Driscoll and Cray fixed effect regression. All of them are significant. Okay, I will store these results. Estimates DKFE, Driscoll Cray fixed effect. The command is estimate store. Okay, then go up and then run RE and then store estimates store DKRE and then Houseman DKFE DKRE. Spelling mistake. So it is still less than 0.05 because p value is not shown. It is showing us that you have to use fixed effect. So DKFE. So you will go up and then start interpreting this model. It has similar coefficients. we use this model instead of the previous fixed effect because there was cross-sectional dependence. अगर क्रॉस सेक्शन डिपेंडेंस ना होती तो previous fixed effect model was sufficient, but since there is cross section dependence, we have to use second generation panel data model. This is the second generation panel data model in static panel data models. So this was the topic for today. We have discussed how to clean the data, how to check if we need to take a log, how to check if we need to take a square variable, and then correlations and confirm if there is multicollinearity. Then confirm if we need to use a static panel data or dynamic panel data. Then first generation panel data or second generation panel data. So in our example, we talk about first generation panel data and second generation panel data within static panel data. In our next example, we will go towards dynamic panel data, first generation and second generation.